Greetings and welcome to the introduction to astronomy. In this week's special topic in astronomy, we are going to talk about the astronomical term extinction and find out a little bit more about what that means. So what do we mean by extinction? Well, we're not talking about the elimination of species here on Earth. In an astronomical sense, extinction has a very different definition, and it is the absorption of light by dust between an object and the observer. So we can see an example of that here, where we can see a very dark splotch in the sky. Now you can wonder what that is. Is that material where there is a lack of material? So is there just nothing there? There are no stars? Or what is really the case? Is there something there hiding that material? And that is what this is. This is an example of what we call a dark nebula. And the dark nebula therefore blocks out light from behind it. And it does this because there is dust in this area. Now, dust is just small particles of material, not very big. And there are just so many of them in this region that they block out the light. Now, they're not super dense. That doesn't mean this is a region of high density of material. But those particles are spread out over light years worth of area. And it just works out that no matter where you look through it, your line of sight hits a dust particle. And that makes the region opaque, not allowing light through. So that dark splotch really has just as many stars behind it as any other part of this image, but we cannot see them. Now, another example of this would be what is known as the Horsehead Nebula in Orion. This is a very prominent dark nebula with the shape of a horse head. And we can see a little portion of that here. And you can see a few stars peeking through. And that really just depends on how you look at this. If you look at it with longer wavelengths are a little bit better able to penetrate. Now, that's because the dust does a couple of things to light. And one of the things it does is block them out, as we've already seen. A second thing that it does is to redden them. And let's go back to our first picture here. And what we see is that what we'll see is that the short wavelengths are absorbed preferentially. Now, short wavelengths would be blue light particularly. So the blue light gets absorbed and the red light makes it through. So as you look at some of these regions around the dust cloud, you will see a number of red stars there. Those red stars are stars that may not actually be red. They may just be looking at them through a lot of dust. And if that dust absorbs out the blues and the greens and the yellows from the light from the star, then all that may be left is the red color. And that can actually change the apparent color of a star from what it actually is to how it appears in the sky. So really, what is the effect of the extinction is that the dust makes things appear redder than they otherwise would and fainter. So this was a difficulty early on when we did not have an understanding of the amount of dust within the galaxy, because objects would look fainter and therefore more distant than they truly were, causing us to overestimate their distances. So let's go ahead and finish up with our summary. And what we've looked at today is we've talked about extinction and how it is the absorption of light by dust between an object and the observer. We've seen a little how it will change the appearance of the star in terms of making it redder and fainter than it would otherwise appear. So that concludes this special topic in astronomy on extinction. We'll be back again next week for another special topic in astronomy. So until then, have a great day, everyone, and I will see you in class.